and welcome. AI has transformed technical debt from an engineering frustration into a boardroom concern. To win in the AI era, leaders need more than speed. They need a healthy code base that autonomous agents can reliably work on. Joining me today are two industry thought leaders. We have Matthew Skelton, co-author of Team Topologies and CEO at Conflux, and we have Adam Tornhill, the founder and CTO at CodeScene. Together, we're exploring how code health directly impacts AI performance, token costs, and your bottom line. And we're going to talk about how COOs, CFOs, and CEOs can make data-driven decisions on technical quality. So welcome. So let's start at the strategic core. Boardrooms everywhere are pushing for rapid AI adoption, but there's a growing realization that AI tools can only perform as well as the code base underneath them. So let's talk about what genuine AI readiness actually looks like. So my first question is for you, Matthew. When you talk to a COO or a CFO about AI readiness, what are you actually telling them?
Literally, I was talking this morning, in fact about 3 hours ago, to a global chief digital officer at a significantly well-known large company, global company. And I was talking about the need to have ongoing stewardship for the value flows inside the organization, irrespective of what they are. Now, you'll not be surprised to hear that I see Team Topologies as a way to frame the organizational architecture to enable good stewardship of ongoing value flow. That's the language I'm using now. You won't find that in the 2019 edition, but that's the language I'm using now. And that really resonated with, those two people on the call, really, and resonates with similar kind of people in lots of different organizations. Because if you think about like digital delivery, so creating of software and digital systems, services, that kind of thing, the thing that AI has shifted, obviously, is instead of writing the code ourselves by hand, we're now using AI harnesses and a bunch of other things to generate that code. But who's responsible? Who's accountable for that stuff? So the team boundary now is really a stewardship boundary. We're still responsible for the runtime success of the things that we're looking after and producing. We might be using some AI tools to actually help create the code, for example. So the starting point really, and this is a significant point of overlap between Team Topologies and CodeScene, and has been a point of overlap for actually nearly 10 years, just over 10 years, but we can talk about that in a minute if you want, is this sense of the health of the thing that we're working on, the health of the code, and the fact that we need to care about what we're doing so that we've got the ability to evolve this system sustainably at a sensible cost in the foreseeable future.
Thank you. All right, so Adam, we talk about AI readiness. In your opinion, what does an organization that's AI ready actually look like? And what warning signs do you see in organizations that aren't?
Yeah, so let's maybe start with the warning signs. So I've been fortunate to work with hundreds of organizations globally. I get to meet a lot of really interesting people. And one thing I've seen is that, and we've probably all seen it, is that there's an enormous pressure right now to not only adopt AI, but also are very high expectations on the outcomes. We expect development to be largely automated very fast. And what I do see is that some organizations are reaping these benefits and others are failing miserably. Mm-hmm. And the typical signs I see is that they run into production incidents. I think production incidents in general are up like 3x. And that was not the 3x that we were expected to accelerate, right? Mm-hmm. Defects are up. And what also happens is that we get new bottlenecks, right? So suddenly we spend a ton of time creating creative solutions for handling PRs, a fluid of PRs.
Yeah.
So I think what we fundamentally tend to miss in the industry is that the code itself, the existing state of your code, is a super important part of any agent's context.
Yeah.
So that's what I've been focusing on a lot over the past few years.
Just to pick on your, you mentioned production outages there. I think one of the things that people forget, it's not very intuitive, is that if you're going to be generating more output and delivering more software, you actually need to get better to hold the line on some of these things. If you're deploying twice as many things and your percentage of issues is the same, you're going to have twice as many issues. I think a lot of people aren't really thinking like that. I don't know if you've got any observations on that. I know Love Holidays talked about this.
Yeah, definitely. So Love Holidays is a great example of an organization that has succeeded with AI, that are getting the benefits. And they are also a great example on engineering discipline. So to me, AI doesn't require less engineering, right? It requires much more engineering at a higher level of abstraction. So all these fundamentals that we have been told for decades that are important, that the industry has largely ignored, they are now no longer optional if they ever were, right? They are absolutely mandatory to get AI to work securely, safely, and sustainably.
Thank you.
And this is something that's not necessarily specific to AI in some respects, because in the 2010s, or from about 2008, we had cloud computing and kind of scalable infrastructure, that kind of thing. To make effective use of cloud, you needed a high degree of discipline. You needed effective organizational structure, effective system architecture structure to enable that velocity, to enable that speed uplift through the use of like what ended up being called cloud native. It's a similar kind of pattern. Just by sticking stuff in the cloud, you didn't necessarily get any good outcomes. You needed the discipline and the other things around it, the hygiene factors around it to really see that accelerated outcome. And there's something equivalent happening with AI. So it's not like a one-off thing that's never happened before. We've got an existing parallel that's already happened within the space of the last kind of 20 years.
Yeah. Okay, so Matthew, I'm going to move on to talk about AI native operating models. And I know you've got a vision for what that might look like. So maybe you can tell us a bit more about what you're thinking here.
I have to be honest, my vision at the moment, I can see the AI operating model on the horizon. For me, it's still coming down the road. It's not right in front, and I don't think it's right in front for anyone really. However, what's totally clear is some of the stuff we've already been talking about. For AI, particularly agentic AI, to work effectively, we need very clear boundaries of ongoing responsibility. We need clarity of intent. We need continuously refreshed context going into that system, whether that context is for humans or for the AI system. And we need high quality code. If you're building digital systems, we need self-service platforms, APIs, where we can consume things without any Jira tickets in sight. Now, all of that stuff, again, has been really valuable over the last 20 years as cloud emerged as a technology. So the organizations that are already set up to do that are going to be able to take advantage of AI very, very easily, or fairly easily. But here's the thing. The number of organizations that really, really went cloud native and really, really succeeded in that space was very small. In many cases, it was just the kind of IT department of larger organizations. What AI is doing is forcing every organization that is doing knowledge work to adopt these new approaches. Organizational architecture, a focus on quality of different kinds, but certainly code quality. Focus on ways of working, focus on self-service access to data, APIs, other capabilities. For most organizations, what we're finding for most organizations is that it seems like AI needs a new operating model, because many people in these organizations have never seen the cloud native way of working. Those of us from technology have got an advantage in that we've already lived through that way of working, and we can bring that way of working into the AI world. So the AI native operating model, yes, there are some details which are quite different in terms of like code generation harnesses and all kind of stuff at the lower level. But at a higher level, the principles, from my perspective, are effectively have already been proven.
Yeah.
I'm a bit biased, as you'd expect, but I do believe that Team Topologies does provide that organizational foundation, that architecture for value flow, on which we can build an effective AI native way of working. So it's sort of new for many people, but actually those of us who have been doing a bunch of stuff in this space for a long time can bring our experience, add a bit of the stuff that is new, but I think there might, in some respects, it only feels like about 10% is new. 90% is stuff we've already proven in the last 20 years.
Yeah, I think I'm sure Adam's going to agree with you, but just to add to that from my own perspective, one of the things that I've been talking to people about is this idea. People talk about fundamentals, but I think there's a difference between a set of fundamental principles and values versus a set of fundamental practices. And I think in some cases with this new technology, our practices need to evolve. But I think fundamentally, to use that word again, the principles and the values that we've had that have worked well for us before haven't really changed. I think that's kind of what you're saying. I think some of the practices might remain the same, but we need to do them even better. We talked about production outages, for example. We need to be even better at protecting against that than we were before. But I don't know if you have anything to add to that, Adam.
So I would like to dive a little bit deeper into the code quality aspect, because I think that's highly relevant. That's definitely part of these fundamentals. So maybe we could bring up the graph here. So this is data from our research that we did earlier this year. And what you see here on the x-axis is the code health scale. And please bear in mind now that code health, it's not just a concept, right? It's a metric as implemented in CodeScene. So it's a deterministic metric. And at the y-axis, we have something interesting. We have something called break rate, which basically shows you how many defects does an AI agent introduce when attempting to change code. And that has been validated by running automated tests. Now, what's so interesting about this is that this is a large-scale study we did of thousands of programs where we instructed agents to go in, make a modification, running the test to see if they did the right thing or not. And what we see here is that break rate strongly correlates with code health. So if we look at the scale, we see that the code health scale is green at 9 and above. That's because 9 is the threshold for humanly readable code. So back in the days when we wrote code manually, a code health of 9 would mean I have a fair chance of understanding this piece of code and change it as a developer. What we see, though, is that at a code health of 9, the break rate, the AI break rate, is already 60% higher compared to a perfect 10. So that means that an AI agent is actually more picky about code quality than a human expert. So to really pull it off with agents, and I talked about this before, how your code base is a super important part of an agent context, we need to push code health to at least 9.5 and ideally aim for a perfect 10, because only so will we be able to keep hallucinations, defects, and ensure that the code remains reviewable.
Okay, so just following on a little bit from that then, again, this one's for you, Adam. So if a CEO says to you, we're rolling out AI coding tools, we're doing it next quarter, what's the first question that you would ask?
Do you know in which parts of the code you will be able to succeed with AI and which parts of your code that aren't AI ready yet?
And obviously, based on the graph you just showed us, what you'd be saying to them is, if your code health's under a 9, I don't recommend that you deploy AI here. I recommend that you uplift this code health first.
Yeah, I would definitely do that. And what we typically see in a large enterprise code base is that parts of the code base are typically AI ready, right?
Yeah.
The code is healthy enough. There's usually strong safeguards around it in the shape of automated checks. Yeah. But then there are other parts, and typically the most business critical parts that are far from AI ready might have a code health of 2, 3, or 5, right? And it would be way too much risk to try to give an agent any autonomy there. So it's really important to get this situational awareness and understand where can I accelerate feature development today, and where do I need to invest into an uplift and quality improvements first, before I can reap any benefits of AI. And of course, that uplift can be largely automated. That's the nice thing.
Yeah, I think you and I both know that the code that you're most likely to be changing is also the code that's most likely to be not AI ready, right?
Yeah, that's usually the case. We see that in our industry benchmarks that we have done that, as I said, AI readiness from a code health perspective starts at 9.5, and the average enterprise code base, the most frequently worked on parts, the hotspots, have a code health of 5.15.
Yeah.
So it's very, very far from AI ready.
So what would you see the impact being, let's say an organization's unaware of the health of their code. They don't know. They don't have the answer to that, but they've decided to go ahead and adopt autonomous AI agents. What would you expect to see go wrong?
So first thing, I think it depends on from whose perspective, right? So if I talk to senior engineers in those situations, the typical feedback I get is that, yeah, we tried AI, it doesn't work at all, right? And
Yeah.
there's probably nothing inherently wrong with the technology as such, right? It's that the context that you're responsible for that's not up to par. What you see as an organization is that you see no acceleration whatsoever. It's typically what we touched on earlier, that you see an acceleration of production incidents and quality goes down, and people
Yep.
tend to lose ownership of the code, right? You lose the mental model of how things fit together because you now found that you have to understand a lot of code that you didn't write yourself. And that's a significantly harder problem than writing the code up front.
Thank you. Okay, so we mentioned Love Holidays already, but I want to talk specifically about that. I'm going to share a graph in a moment. So I'd like us to discuss as a group the success story of Love Holidays. And what I really want to home in on is what we see as why were they successful? How did they enable that success? And what could other people potentially learn from that? And I'm just going to share the graph just now. I don't know, Adam, I don't know if you want to start and then we can let Matthew join in.
Yeah, sounds good. So I can start and talk around this graph. So what I find so fascinating with Love Holidays is that they had a strong engineering culture pre-AI. So when they decided to go all in on AI, which is almost a year ago, so it was June, July in 2025. So we see that in the yellow graph here, right? So that's where they started to adopt AI for real. And the blue bars show their hotspot code health. And remember that hotspots are the parts of the code that you're likely to change the most. So these are typically the ones that are driving costs and risks. And what we see here is that there is a dip in code health immediately when adopting AI. And this is exactly what we see in our research, that unguarded on AI agent will decline your code health. But fortunately, Love Holidays, they have always been quite data-driven, as we see here. So they had CodeScene back then, and they immediately noticed they got warning signals from CodeScene that your code health is declining. This puts you at risk. And they were really quick on acting on that. So what they did was that they used our CLI tool that integrated into Cloud Code that they used back then. Today, we have a code health MCP, but we didn't have that a year ago. So they used our CLI. And the moment they introduced the CLI starts to send feedback to the agent, right? Telling it that, hey, you're doing something wrong. Here are the problems that you introduced, very specific information. And agents are capable of picking that up and acting on it. So we see that a month later, after this drop in code health, the code health was back to the previous level. And from there, they had just improved on it. So they are now running, as you see, in an AI healthy space, right? 9.5, almost 10, which is really, really great.
Yeah, so they've achieved a huge increase in the AI commit rate, and they're at a better code health than they've ever been at the same time.
So this is the unique combination of speed with quality.
Yeah. I think on the subject of the CLI tool, I've been a CodeScene user for years now, and it isn't something that I'd ever thought of doing, and it's a brilliant thing to do to add that as a pre-commit check. I learned it from the Love Holidays guys, and I think if people that are watching this are already users of CodeScene, I think putting a pre-commit hook with the CLI tool is an excellent way of protecting your code health. Okay, so Matthew, would you like to add anything to that? Do you have any observations around Love Holidays and what you see that made them successful?
One thing that's not visible from this graph here, from this chart, is that they use Team Topologies to help them think through how to organize their capabilities, the way that code gets built. And that almost certainly is a contributing factor in their ability to even think about building software in this way. Because if you using Team Topologies, one of the key tenets there, like I said before, is thinking about how do we look after this product or service or value flow more generally. How can we be good stewards of this value flow? If we're in a position, if we're using something like Team Topologies, then we're really thinking about the quality of what we're doing. We're thinking about sustainable value flow that fits directly within the concept of code health. Because code health, then we're thinking about the health of this thing that we do, the health of the materials, if you like, that we're using, code as it happens to be, but the health of the thing that we're working with. Because if we keep it healthy, we'll actually get better outcomes. Contrast that with other ways of doing work, other ways of doing software delivery, where you've got individuals jumping in and out of different parts of the code, not really bringing any context or anything like that, not bringing full awareness of how this particular part of the code works or how that part of the code works. They just kind of squeeze in a new feature. That was a traditional way of doing software development for maybe 2 decades. That approach just doesn't work in this context. Like, it clearly is not going to give the right level of awareness to be able to care about the code health in these different areas. So I think I'm actually going to go and do a bit of a deep dive with the Love Holidays engineering people in a few weeks' time. So I'll find out more. Fingers crossed, I'll actually speak at their internal conference in October as well.
Yeah.
But the key point here is this relationship between the teams and the code. And I mentioned before that there's been a relationship between CodeScene and Team Topologies for nearly, well, more than 10 years. It's actually the precursor, I think, to CodeScene. Adam, is it CodeMat? That tool? I found some slides from a conference talk in 2016 that I did in Amsterdam, and it had a picture of your book from then, and I think a precursor to CodeScene, or something that you'd done before CodeScene. I've been thinking about these things for at least 10 years and thinking about the relationship between.
Matthew. You beat me by a year. I think it was 2017
Brilliant.
that I became aware.
2017 for you. But this relationship between teams, a sense of looking after the code, that's super important for me, and it's borne out. You know, it's embedded there effectively in the Team Topologies ideas, and it's now being borne out in this AI assisted or agentic coding world, because without that ongoing care about the quality, you can't get any useful speed out of using AI. So there's a nice ongoing relationship there that's literally been there for more than, like, Adam and I, like, we talked for 10 years effectively around these kind of things, and it's amazing to see this really paying off for you, Adam, and your company, because I think it wasn't necessarily clear back then in 2016 that these kind of ideas we knew they were important, but to other people it wasn't necessarily as important. Now what AI is doing is shining this big light on everything, saying actually you do need to care about the health of the thing you're working with. That's the way you're going to get good business results. Okay. So I think it's probably a combination of it's not just using. It's using CodeScene in a very clear way, but underneath that, I think, is almost certainly a sense of ongoing stewardship of these different products and services that they're building, and that's what enables them. The combination of those is probably what gives them this ability to make the decisions that they made effectively across the organization.
Okay. All right. So now I'd like to shift us into talking about the C-suite conversation, and I want to talk a little bit about the communication gap. So for years, engineering leaders and executives, I think, have struggled with hearing the term technical debt. I think as engineers, we've got a lot to answer for in that. I think we've generally struggled to articulate why technical debt matters and why it should matter to executives and leaders. And I think that even more than ever, it's becoming important that we translate the concept of code health or technical debt into something that's actionable at a board level and something that can create company-wide objectives. So the first question for you, Matthew, is talking about the CodeScene as a bridge between technical concepts and executive decision-making. Could you walk us through an example of a conversation you had like that?
I've been working for a few months since earlier this year in 2026 with a company based in Central Europe. They're doing some amazing work, and we're actually helping them to introduce Team Topologies as an approach. Now, because of the nature of what that company's doing, it's very technical. There's the vast majority of what they're doing is software based. They want to go more. They want to be quicker. They want to get to market more quickly because it's quite a competitive space they're working in. They've got lots of complexity because of the domain they're working in. They've got some smart people. That's fine. That's the kind of people they need to hire to be able to, like, they've got people with PhDs and really understand complicated algorithms and all this kind of thing. But we're helping them kind of reshape how their organizational architecture, including the systems, look in terms of value flow. So all fine. I sat down with the CEO, the founder and CEO of this company, for lunch the other week. And we were chatting about this and that because he was interested in the work that we're doing. And we got onto the topic of technical debt. And he says, Matthew, I'm tired of hearing about technical debt from engineers. Like, it always really, he was like this. And he was like, they just
Can
say
we have
technical debt. Yeah, exactly. And that was one of the conversations that had actually happened in, I think last year, was we need to take whatever 18 months or we need to take 6 months to go and fix all this stuff and then we can start working again. And clearly that's just not viable from a business perspective. It is almost never viable. And to be honest, when you've got tools like CodeScene, it's never needed. And I think that was the light bulb moment. So we were talking about this stuff and I said, look, what if there were a different way to approach what the engineers are calling technical debt, but that allowed you to zoom in and find the kind of hot areas. I didn't call it hotspot, but the warm areas that always get changed because there's high risk. And if you could predict where the bugs would happen because of where the change is happening, I said, what happens if you could have some way of looking at effectively the cost of change? Like, is the cost of change going up, or is the cost of change stable, or is it going down? And he said, Matthew, that's exactly what I want. I want to be able to make targeted investment in improvements. Mm-hmm. And I said, well, you can have that. There's a tool here called CodeScene. He's like, this is what I need. This is exactly what I need. So it's understanding that executives are happy to invest to improve things that matter, like cost of change. They don't want cost of change going up. They want cost of change at least stable or going down. Yep. And they want targeted investments, which are risk-based and which are actually going to make some real business like improvements, not just a blanket take 6 months out to reshape it all. And he went from I hate this technical debt conversation to yes, I want to buy the tool.
Yeah.
So it's possible to frame it in these terms. And what I love about CodeScene is the way that enables that kind of conversation. Yeah. That's why I'm effectively a super fan. Like, genuinely, CodeScene is the one piece of software in the world that I wish I'd written. So Adam, you got there first, and thank you very much for doing it because I could have done it myself. But genuinely, like, it enables those kind of conversations, and it's such a game changer.
Yep. So you must be reading my script here because I've got a question for Adam now. So just on this topic, the first thing that I heard come out of Adam's mouth, it was in 2017, and he said, tackling technical debt like time and money matters. And that's what you're talking about here. And that was the thing that resonated with me was, all right, we're not just moaning about code anymore. We're talking about a business impact. So Adam, that leads me perfectly into the question, how do you make hotspot code health feel real to someone who's never written a line of code? So has there ever been a sort of aha moment? We've obviously just described our aha moment for you, but from your past meetings with customers, can you describe where you've experienced that, where you've shown someone what we've just been talking about?
Yeah, definitely. I have a couple of examples. So the way I typically introduce hotspots is that I tell executives that hotspots send a positive message. They tell you that, no, you don't have to fix all your technical data, right? So to make the metric real, I think it's really, really important to be clear that it's not just a vanity metric, right? It's something that really, really correlates with development time, how fast are you going to be able to ship your next feature, and quality, how many production defects are you going to experience. And it turns out that if you have healthy code, then you can expect up to 10x faster development, and you can expect 15 times fewer defects than someone that has unhealthy code. So that's usually enough to make it relevant. And I had this experience. It's a couple of years ago. It was really interesting. So I sat down with the CEO of a fairly large Swedish company. And CodeScene, as you know, has all these visualizations, right? So we have a map where you can see your hotspots, where you can see within context of the whole code base, right? You can see millions of lines of code at a glance.
Yeah.
And I walked him through the hotspot concept, told him what it means. And then we looked at the hotspot code out, we looked at visualizations, and he grew more and more silent during that conversations. And that's always something that concerns me. When an executive grows silent, you know you're onto something. And then he thought for a minute, and then he said, now I understand why my CTO left.
Yeah.
So that was a person, obviously a really talented guy, but no prior coding experience, right? Never written any code. Now suddenly he could understand million lines of code, or at least the risks and impact at that scale within our 10-minute conversation. And that to me is real power.
I agree. Yeah. I think one of the things about hotspots, that statistics that I found fascinating when I found out, was 2 to 4% of your code is where you spend 20 to 70% of your time. I tell people that's one of the key things that I tell people when I meet them. And most people are surprised by that. I think when you tell them, they sort of go, oh yeah, that makes sense. You know, it's a kind of obvious thing once you know. But that's basically the crux of what we're saying here, is where you spend most of your time, that's where the unhealthy code's really hurting you.
Yeah, exactly. And that's also where I would, of course, focus modernization efforts, refactoring efforts in the case of an AI adoption, right, to mitigate risk.
Okay,
if you can get to the point where you've got the COO who's thinking about operational efficiency and all that kind of stuff, if you can get the COO on board using CodeScene or a tool like CodeScene, but I don't think there's anything equivalent at the moment in the marketplace, you've done a really good job, Adam. If you can get the COO interested in driving operational improvements through into the engineering area with code, then you're onto a winner, because they're happy to fund things because they've got the calculations there to understand like what level of investment is needed to get a better return. So I was literally on a call with the COO of a large insurance company in Asia fairly recently. They actually had CodeScene in there. They were trialing it, but they were trialing it at the kind of engineering level, if you like. And the COO was aware of the tool, but didn't really see the value. We reframed it in terms of, well, think about this in terms of tracking, cost of change and risks and things like this. He was like, I love it. I want this. Let's make it happen. Like the key part of this thing is that translation, like we said before. What do the executives actually need to care? What are they required to care about? And therefore, what do we need? How do we need to talk about, in this case, like code and digital engineering, in terms that they actually care about? CodeScene provides a significant kind of translation layer, effectively, or like window into this problem for people who are outside of technology, and it's hugely valuable.
Yeah, I think, Matthew, as someone who comes from an engineering background, I would say articulating why these things matter to COO, for example, I would probably call that God's work, because for me, I think for a lot of engineers, someone like you helping that conversation is massive for them, because a lot of engineers do struggle to articulate these things well, and they know that it matters and they care about it. But I think having someone like you supporting them and having that conversation at board level is massive for engineers, because you've got someone who's advocating for the things that you care about, but is able to articulate it in a way that is listened to by the leadership team. I think that's always been a big challenge for engineers.
Exactly. And so there's me talking about it in those terms, and that gets the interest. And then we use CodeScene to dive into the actual detail. So it's the combination of heart and head, if you like. I can articulate it from a conceptual perspective, and then CodeScene is providing the actual metrics to demonstrate where to actually focus. And it's a simple but powerful combination, effectively.
Thank you. The next part we're going to discuss is around technical debt and how it is associated with financial risk and the costs of using AI. So we're talking about the bottom line. So we haven't just changed how we do software development with AI. It's completely rewritten how we budget IT projects. And I think we all know that we've been living in a subsidized world, and we know that the costs are going to go up. It's inevitable. It's not sustainable right now to be paying £20 a month for £2,000 worth of inference. So I want to talk about those financial realities. I want to talk about the strategic risks that boards need to be watching. And I'm going to kick that off by talking about some research that CodeScene have done. And that's around how technical debt, how code health correlates with the amount that you will spend or the number of tokens that you will use. Maybe we can talk a little bit about what we're seeing out there in the industry. So yeah, without further ado, I'm going to share the slide. I'll let Adam explain the research.
Yeah, sure. So what we did here was that we, again, asked multiple agents, I think all the large agents, various LLMs to support them. We tasked them with making changes to existing code. And what we saw here was that depending on the code health category, an agent is going to use more or less tokens to do the same task. And what you see here is the contrast between changes to healthy code versus changes to unhealthy code. And we see some variation between various programming languages. But in general, so if you work in unhealthy code, you're going to need between 35 to 45% additional tokens to achieve the same thing. So the takeaway here is that unhealthy code not only puts you at unnecessary risk when it comes to AI-induced defects, it also significantly increases your token costs.
One of the things that I thought was interesting, Adam, was that before AI, when we talked about the benefits of healthy code, one of the things that we said was unhealthy code, a task takes, I think, 43% longer was the statistic. And what I find quite interesting is that 43% for a human in terms of how long it takes to perform a task is very, very similar to these numbers. Do you have any thoughts on that? So the way I usually explain this to people is it doesn't really matter if it's a human or an AI doing the work. You'll have a roughly 43% additional cost, whether that's in tokens or time. You can merge those two things together. I don't know if that's something you've noticed and what you would say about that.
So in general, what I see in our research is that there is a very strong overlap. So code that's good for a human is good for an AI too. So there is definitely a strong overlap there. But what I also think is that the actual token waste might be even larger in an enterprise context. Because in this research, we didn't have access to code that's really, really low in code health, right? So here we had to do a cutoff at a code health of 5, 6. But a lot of enterprise code bases out there have a code health of 2 and 3. And I can easily see that the token waste, we might talk multiples here, orders of magnitude differences, right?
Yeah, I did some testing myself, and with Sonnet, I tested on a very unhealthy piece of code, and it was like 10 times. It was about 10x. Not a control test in any way, but something that I personally ran multiple times on a piece of unhealthy code, and I was seeing a lot more than 45% increase in unhealthy when I was down in the 1s and 2s. Okay, Matthew, would you like to add anything to this?
I mean, so I've not been involved in this level of research. I think it's amazing, Adam, that you're doing this is super valuable. I think what's happening here, if you think about it, just take a step back from like from the level of Java versus C++ or Python. Software at the level that we're talking about, as in business software, which is mostly talking about here, is a representation. It's a representation with a degree of fidelity towards the ideas it's trying to represent. Obviously, when you're programming like a mobile phone or something, you're talking about bits and bytes and I/O lines and memory registers and a load of that stuff. Fine, it's talking about hardware. But let's just think about the vast majority of code, which is much more at the kind of business level. We're representing transactions. We're representing financial accounts. We're representing an order. We're representing these kind of things.
Yeah.
So there's a level of quality to that representation. How well are we representing the concepts of an order or of a transaction or of an account? And if they are well represented in a way that's easy for humans to read, it's not surprising to me that it's also easier for a tool to parse that, like an LLM tool, to use an AI agent to use that, because the representation of the ideas is fundamentally clearer. Mm-hmm. So it doesn't surprise me at all, because effectively that's what, at this level, that's what code really is. It's about representing concepts clearly. Yep. And yes, executing it and turning it into machine code later on, that's fine. It doesn't surprise me at all. I mean, I've given talks and written articles that talk about this. I've been saying this probably for 2 or 3 years, like since sort of before some of this data was coming out from sort of AI-based research and things, because for me it was important to really understand what enterprise code really is. And like I said, when you see it as let's say a variable level, a representation of business ideas that have a variable level of quality, surely the best outcomes are going to be from having a really good level of quality to represent those ideas. Otherwise, those ideas are not going to be represented well, and you'll have problems either in how that stuff executes, how well is that business process executing, or in terms of how it recovers from errors, or there's just too much in there and it's too convoluted, and it could be a lot simpler.
Yeah.
And so therefore higher quality is going to result in easier, more straightforward change and evolution of that code, those ideas over time. And yeah, so maybe it's just a correlation. Maybe there's something else going on. But to me, given that it seems to me that code is acting like a representation of concepts, the higher the quality of representation, the easier it's going to be to work with and change. That to me seems pretty clear.
I think that's spot on. So to me, the hallmark for a really good software design was always that that we closed the gap between the problem domain and the solution domain, right? So that as humans, we could rapidly iterate on our ideas in code. And it's the same thing with an agent, right? So if you manage to bring these two representations of the problem we're working on and the solution that is expressed in code very close together, everything becomes simpler, right? It becomes easier to search and find a relevant part to change. Reasoning can become local, and it's much, much easier to translate the intent we put in our prompts into working code. So absolutely agree with that. I think it's a really important point.
So taking
I think that speaks. Yeah, go for it.
No, please continue.
I was just going to say, I think it relates strongly to how, to like a board level, an executive level misunderstanding about what code really is. Yeah. Because when you speak to some executives, they just think coding is like typing out instructions.
Yeah.
Rather than rather than people or something taking the time to represent ideas really accurately. So yes, we might not be typing out the code now in Python or Java or whatever, but what we are doing is putting the context in place, putting the prompts in place, putting all of those guardrails in place to result in code generation that is highly accurate.
Yeah.
And that's the thinking is still needed. That thinking, that care for the domain fidelity is absolutely, in fact, is more needed now than it was before.
Yeah.
And the nature of, and therefore the importance of like code quality is elevated. But if the executive or senior leaders still don't understand what code really is, as in it should be a high fidelity representation of business intent, if they still don't get that, then they're not going to invest in improving code quality. So there's a job to do to really reframe how for leaders, like how to think about it. Because as soon as they realize, well, why on earth, if you talk about business intent like that, then certainly for regulated domains, they'll be like, well, we absolutely need to make sure that our business intention is represented accurately. Otherwise, we're going to get fined by the regulator.
Yeah.
So then you can say, right, well, you need to invest in code health, in the health of this code base. But there is a translation, there's a different mindset shift that's needed, I think. There.
You sort of started to answer my next question, but I'm just going to extend it out and I'm going to combine it with the next one. So the original question I was going to ask was, how has the board level conversation changed around technical debt in the last 18 months? However, I think the premise of that question might not be quite right, because it assumes that the conversation has changed, and I'm not entirely convinced it has.
I don't think not yet. It might be shifted somewhere, but
I think we've still got a lot of work to do there. And the second part is specifically around the CFO in this conversation. What do they need to see? Like what metrics, what framing do they need to see? How do they approve investment in code quality? How do they understand technical debt? And I was going to ask what shifted with AI, but I actually think, listening to you guys talking, what I feel is there's actually an opportunity, a renewed opportunity for us to have this conversation that I think the three of us have been having for decades now. But we have a renewed opportunity to have this conversation in a context where there's a significant new cost to software development. And, we can renew this conversation about why it matters with the right people in a different way. So I'll leave it open to you guys to give me your views on that specifically, and then we'll close the section off and go to the close.
So if you think about what happened with cloud, out of cloud was born FinOps and all of that like financial operation approach, because with cloud you've got every like part of the stack is traceable through to a single P&L and all that kind of stuff. So that enabled a different way of doing things, and you can have a proper conversation with the CFO. There's going to be an equivalent, or there is an emerging equivalent conversation around AI in general, which includes stuff about token cost and code base health. And clearly, like CodeScene has got a part to play in enabling that conversation. And the research that you've just shown, Adam, like is part of that. I've not yet started to have that conversation because I'm not close enough to it at this point. But I know that conversation is coming down the road for sure.
We need to have it. I think we've all got a responsibility to make people aware of this, I think. Adam,
presumably, Adam, you would take that extra 45, 43, 35% token usage and then convert that into a dollar figure, right? And say, well, and then you can say, well, if your code base health is somewhat healthier, then your extra token cost is only 15% or 20% or something. So you can translate it into a dollar cost, and there'll be a break-even point at somewhere where the CFO is like, right, I'm going to invest 15 million to improve the code base health across this because I'll get ROI in 6 months.
I think the question
feels like it is
how much are you currently spending on tokens, and what is your current code health? And I think once you have those two pieces of information, you can very quickly articulate a business case for doing the right thing. If I can say, you just spent 300,000 last month on tokens, your code health's a 4. If we take it to a 10, I'll half your token bill. That's a business case on half the page right there.
And you overlay on top of that the likely increases in token cost.
Yeah.
Then
exactly.
Your time horizon is shrinking.
exactly. Yeah, you're running out of time. This is going to get really bad really quickly. Adam, would you like to add anything?
I agree on what you said. I think it has never been easier and more natural to build a business case for improving code health.
Yeah.
And I mean, the cool thing is that, yes, there are very real financial benefits, but you also have all these other benefits that are so important, right? With shorter development cycles and higher quality on your deliverables, which will translate into an increased product maturity experience and happier customers. So I think there are like 3 big wins to get there in the AI space with code health as the foundation.
There's another big win that I, as a customer of CodeScene in the past, was my primary concern in at least one case, and that was developer experience. I think we often forget about that, and it is hard to articulate that at board level as being something that matters. But engineers don't like working in a mess. I generally find good engineers don't, and I think if you see engineering as being an important part of your business, and you value retaining your good engineers, that is another benefit that I think we often don't talk about. I don't know if you agree on that, Adam, but certainly I prefer working in clean code.
Oh yeah, definitely, and in particular with the AI, if we think back to the first curve we looked at on the code health and AI break rates as a function of each other, and it's very clear that it's so frustrating to work with the AI on unhealthy code because the AI is going to get it wrong. You're going to spend a ton of time iterating, and after a while you have no idea what's going on anymore. It's virtually impossible to give the AI any type of autonomy, and that kind of takes away all the big benefits that we look to unlock with AI. So I agree, there's a strong link to developer experience here.
So Matthew, maybe you can tell us a little bit about how Conflux and CodeScene pair up, and how that benefits your clients, your customers.
Sure. So one of the deliberate distinguishing factors we've got at Conflux is we're bringing deep awareness of technology and technology adjacent practices, but we're not starting with technology, we're starting with business outcomes. So when we talk to, the typical kind of person I speak to on a daily basis now is C-suite or -1, so kind of VP of engineering or VP of head of HR or head of AI or this kind of thing. These kind of roles. In many, many cases, these people do not have an understanding of the technology underneath, and that's obviously absolutely fine, and as you'd expect. Now AI is with cloud computing. Some executives needed to know a little bit more about how kind of cloud computing worked to be able to make better decisions. With AI, more leaders are needing to understand effectively, to some degree, how AI works or some technical details to make better decisions. However, we cannot expect these leaders in these situations to devote much time to the detail. And so CodeScene specifically enables us at Conflux to be able to have a much more focused conversation about software, about code, digital products and all that kind of stuff. It enables us to have that kind of conversation at the right level, which unlocks the right leadership decisions and investment in improvement and so on. Whether it's head of product, or whether it's COO, or whether it's even some cases CEO, whoever it is who's making the decisions, because of the way that CodeScene can surface, it can bring to the surface the things like the kind of hotspot, the risks effectively. Risks on lots of different dimensions, right? There's the offboarding risks, there's code change risks, there's a bunch of things like this, but also looking at coupling, saying, look, you've got two parts of the system here and here, they always change at the same time, but that the knowledge that they need to change is clearly in somebody's head because it's not actually mapped inside the code itself. That's a risk, and so on and so on. To be able to articulate these kinds of things to execs who need to know a tiny bit about the detail and no more. And that's hugely powerful. We're effectively putting all of that quite complicated stuff about software delivery and code and things through this lens of CodeScene, and presenting it back out to leaders who can then make a genuinely informed decision based either on a map of risks or based on a list of hotspot areas or a dollar value that relates to like token cost or something like this. It genuinely transforms the conversation, and it's a nice combination, because at Conflux we can go and have those conversations, but then of course at some point the leader quite rightly says, well, show me the data. So then use CodeScene to show the data effectively. So it's the kind of tool I love to use because it enables those kind of conversations, but in a way which is grounded in accuracy and reality. It's not making up figures. So I can have the confidence to have a proper conversation with people at that level, knowing that CodeScene is representing things in a way which is non-trivial. So it's got a non-trivial view of the code. It's multi-dimensional in terms of code health. Obviously, you got the patent, and it's been validated in a whole bunch of different areas. So I've got the confidence to be able to say this is a really effective representation of what's going on.
I think being armed with information that you can trust is huge. I think
exactly,
because you could ask 20 engineers about their code and you'll get 20 different answers. And I think having something that's clearly measurable, walking into a conversation like that is a huge advantage, especially when you've only got 2 minutes or 15 or whatever.
And like I said before, these leaders want that conversation. It's not that they're trying to avoid it. They want the evidence. They want something that enables them to make a better decision. So this is my experience. Like it goes from black to white. Like it's chalk to cheese or whatever. It's these leaders are desperate for tools like CodeScene to enable them to make way better decisions about technology, but particularly code, in a way which means they don't have to go and dive down into the details. And CodeScene is doing that.
Okay, so before I close here, Adam, would you like to say anything before we close? And then I'll just wrap up.
No, I think I'm good. I don't have anything to add now.
Great. Okay. Well, it's been a real privilege. I really appreciate being asked to do this. It's nice to sit down for an hour and talk to two people like yourselves. A real privilege. And thank you very much for your time. I think for me, the thing that I like about spending time with people like you is that we all care about quality. The word quality came up quite a lot in the conversation. And I know we're not, I think people who really are passionate about quality can be quite rare. So it's a pleasure to spend some time with people who are like-minded, and thanks very much again for your time, and I'm looking forward to working with you both in the future.
Great. Thank you, Daniel. Thanks, Adam.
Thank you.
Cheers.